All right, it is 11 a.m. Eastern Time on the dot. Welcome everybody to SIGGRAPH SOIREE Virtual Symposium. I want to thank my previous hosts, Nick Justishin and Glenn Goldman. I want to thank you both for preceding me and getting us off to a wonderful start. My name is Mayette Andreasen. I am an instructional associate professor at Texas A&M and one of the members of the SIGGRAPH Education Committee, and I am excited to present our first session speaker, Samuel Silva from the University of Aveiro. He is going to tell us about doctor post-processing, or how they started engaging and love the convolution.
Hello, I'm just going to start and share my screen. I have a few slides. Okay, thank you very much. Hello all. So thank you for attending this presentation, and thank you for the opportunity to be here presenting some of the things I did to try to engage students with image processing in a course I lecture. My name is Samuel Silva. I'm from University of Aveiro. So the context for the work I'm presenting here is the Master in Digital Game Design at the University of Aveiro. It is a course, a program that is based around a project-based learning methodology, and it is taught to a diverse set of students coming from computer science, bachelors in game development and multimedia, which leads to challenges in how to adapt the curriculum to each of these profiles. And I'm particularly teaching a visual computing course dealing with topics like computer graphics, image processing, and computer vision. One of the challenges I identified a couple of years ago when I reflected about this course in aerographics was that some of the changes between these modules, for example, between computer graphics and image processing, were not being done properly by the faculty, that is me, I suppose. One of the issues was that, for example, when they transitioned between computer graphics and image processing, this also entailed a transition between working with OpenGL and Pygame and then moving into OpenCV, so a traditional approach to moving into image processing concepts. And what this resulted in was that somehow, since they were already engaged with a mini project they have to do, mostly entailing computer graphics, they did not perceive image processing as being as much relevant for the project. And this often resulted that they somehow disengaged with the topic to spend the time working on their more interesting project than working in the lab with image processing. And the change I came up with, the reframing I came up with was, so instead of talking about image processing and all the concepts, I suddenly started by saying, hey, this is post-processing, and this is important for working with shaders in games. And let's just start with the main concepts around building these post-processing shaders. And then voila, I entered into image processing. So I kept the same concepts I was lecturing about image processing, point-based operations, neighborhood operations, convolutions, but instead of applying them in lab guides, as is often done using Visual Studio Code, Python, OpenCV library, and of course the Lena images, I started teaching them the basic concepts and then applying them in building post-processing shaders inside the game engine Godot. And the other difference was that when they were doing it with OpenCV, they were doing it over static scenes. And now they do it over dynamic scenes on 3D games, for example, as you can see in the image. So what are the first observations? I did this year for the first time. And one thing I noticed is that the adherence to the practical activities regarding the concepts of image processing increased a lot when compared with the previous approach that used OpenCV and the traditional approach to image processing concepts. Also, the inclusion of post-processing shaders in their final projects, demonstrating their mastery of computer graphics and visual computing concepts increased also. The exposure, and this is, I think, one important point, the exposure to post-processing methods increased, and this is important for all the students. But mind you that I have students that come, for example, from multimedia and don't have the technical skills to do a lot of programming. And so introducing it this way and inside the game engine also allowed these students to make a contact with these post-processing methods and to get a notion of how do they work and how do they can be changed, for example, to serve their artistic goals. And finally, the transition was much, much smoother between image processing and computer graphics from my perspective, lecturing, and also from the perspective of the students looking at the different concepts. And another interesting aspect I found was that these image processing concepts started appearing in conversations with students, for example, or during the final presentations of their projects. Suddenly, topics like thresholding, segmentation, kernels, edges started appearing when they were explaining their technical aspects of the project. So overall, I managed to somehow engage the students with the image processing concepts. Now, reselling them as post-processing techniques, I think with apparent success, at least for this edition of the course. And this then created another aspect for me to work with, which is now some students said, hey, teacher, this was very, very interesting. It's a shame that it appears at the end of the course. How about showing this all at the beginning of the course for us to understand where we will reach at the end to motivate us further to follow the path of the course. So thank you very much. This was my presentation. And of course, I'll be open to questions. Thank you.
All right. Thank you so much, Samuel. We are going to move forward with all three of our presenters in this session, and then we will have the Q&A after everyone has presented. So please get your questions ready for Samuel. That was very interesting. I love that. I actually have some questions I would ask you.
Cool.
All right, next we have presenting Damian Thorn-Hauswirth from East Stroudsburg University, and he will be speaking about Animating the Landscape, a service learning collab.
Hi there, thank you for the welcome. So I have a fast forward video. I'm gonna go ahead and share my screen here. My name is Damian Thorn-Hauswirth, Assistant Professor at East Stroudsburg University. We are a smaller to mid-sized university located in the Pocono Mountain Range. This offers us the unique opportunity for service learning projects really integrated with our natural surroundings. We will be making an animation which will be projected on top of a 3D topographical map of Monroe County. Over the summer, I worked with a student worker on developing a prototype projection. We tested translating real-world lat-long data onto the 3D printed surface and made sure we had a framework for being able to do both data-driven and handmade visuals on this installation. Next semester, my students will create their own animations depicting phenomena like migration patterns, water movement, road networks, and more. I find service learning projects like this really excite the students, engage them with not just animation and the techniques, but with their surroundings, with how audiences interpret and interact with their work, as well as all the different applications of this medium. Thank you so much for having me. All right, and that's my fast forward video. Hopefully that went through okay.
No, that was really cool, actually. I love that.
Perfect.
I'm excited to hear more. Thank you very much, Damian. All right, so next we have Rehan Zia from the National Center for Computer Animation, also known as NCCA, in Bournemouth University in the UK. And Rehan is going to present Beyond the Obvious, Instilling Fundamental CG Knowledge and Workflows Through VFX Camera Acquisition.
Thank you so much, Maya. And let me quickly share my screen. Hello, everyone. So I'm a principal academic lecturer in computer animation and visual effects at NCCA Bournemouth University. I teach a number of things from practical camera in the studio and lighting in CG, match move, photogrammetry, and comp. So one of the key things with games, animation, and visual effects is that the understanding of light, camera, and lenses is fundamental, as the final images are rendered using virtual cameras, and the medium that the students work with is light itself. So therefore, it's imperative that the students have an in-depth understanding of light behavior, properties, and alongside the knowledge of cameras and how lenses work. So just in terms of terminology, the course, if I say course, it refers to the degree, and the unit is the module or subcomponent of that degree. I teach 3 units. Historically, I've taught these 3 units. They've changed now, evolved. One is visual storytelling and pre-visualization, which is stills photography, photography craft, but with digital cinematography aligned with that. Visual studies is more about using cameras and drawing in traditional media to deconstruct real-world natural phenomena and object properties and so on. VFX photography and acquisition is more craft-based, production-based, green screen, location, lighting, and so on. So in terms of craft practice, then we do use a lot of different equipment in studio. And what it does is, because you're working in the environment, you've got the subject and the tools and the creative intent all kind of bunched together. You are doing some rapid reflection and action. As you're taking pictures, you're thinking about what you're doing, but also contemplating on the results. With visual storytelling and pre-visualization, we start off with looking at different lenses, focal lengths, camera angles, depth compression, depth of field, and so on. Looking at tonality, just working with monochromatic images, and just really getting into light behavior and light properties, isolating light, so which will feed into light linking. And rather than light linking and students, adding 200 lights in their scene, it's about making sure that they work in a way that is conducive. And looking at then compartmentalizing light and using color, symbolic color, doing 3D reconstructions, looking at silhouettes. All of the groups, the subgroups have basically a large TV screen that the camera is linked up to. So it's real-time feedback and preview. The assignment for this unit is a storyboard, which is photography based, coming from the Mad Hatter's Tea Party from Alice in Wonderland, with some constraints. And the students do really, really well with this. Visual studies, as I said, was more the BA Technical Arts unit, which was very much about deconstructing phenomena, and the assignment brief is very open-ended. They could do anything from gesture, weight, fluid properties, whatever they want to do. So this is just a very quick overview, and they had to build their study up as iterative practice, which is what's been done in these 2 assignments here that I've shown. Very quickly moving on to VFX photography and acquisition, which, as I said, is about green screen and using green screen and match move and image-based lighting, set survey and such. So we work on location. We also work in studio at the same time. And so, sorry, skip that quickly. So we have, in terms of the more obvious kind of craft skills and photography skills, we're looking a lot at color, how light behaves, how camera works, how the sensor artifacts, lens artifacts, chromatic aberrations, all of these things that they will need to use even if they are not working with visual effects. So this is basically on one of these photography sessions, image-based lighting with photogrammetry of 2 students sitting on a bench, give more realistic reflections. Looking at distortions, depth compression, depth of field, lens flares, halation, glows, sensor artifacts, as I mentioned, Bayer pattern issues, Moira implications with LED walls, digital file formats, bit depth distribution across different formats, raw files and such, energy dissipation, inverse square law, why diffuse and specular needs to add up to 1 or can't be more than that. Caustics, light behavior. So this is in a way very much laying the foundations for everything that they will be doing more in depth in CG. Compression types, artifacts such as banding, dithering, raw files, and thinking about color vision and where RGB comes from, and color spaces and gammas and wavelength and image-based lighting, color temperature, the fact that the camera doesn't distinguish between light emitting surfaces and light reflecting surfaces, and then thinking very much about tonality, normalizing textures, getting rid of highlights, not baking in shadows and highlights, scene scale, really important for match move, and so on. Parallax, different types of photography and camera shutters, motion blur, but also looking at photorealism and realism, and looking at the kind of issues that the camera brings in with the lens and sensor artifacts. And how we go about thinking about it in terms of compositing workflow. So denoise, why do we have to denoise first and then undistort the lens second? Why can't we do that the other way around? So all of these things feed into different disciplines such as concept art, storyboard, visual development, art direction, and there's the full list there. We do touch upon virtual production, not so much with the screen, the LED wall as so much, but we have used it for experimentation in the past. So I'm just over time, so thank you very much. Stop here.
Fantastic. Thank you very, very much, Rehan. That was excellent. All right, this is the Q&A portion of our session, and we have a question actually in the Q&A area. I believe that this question is for Damian. It is, how many reference points did you use? Do we have maximum at this moment? This is 2D simple projection of 3D motion. Have you tried any motion in 3D perspective?
So let me wrap my head around each portion of that. Maybe I can just describe the overall setup and it might make a little more sense here. So it's like a 3D topographical map. So we're projecting onto like a 3-dimensional surface from just a standard overhead projector. The tricky part of this, like the setup of this project, is this whole map was created in another course, essentially, with students sort of figuring out how to get the data and 3D print it. That data I didn't have. So I didn't actually have like the source model files for that real world map. So part of it was sort of translating the latitude longitude data, which I downloaded from various sources, and being able to like set up this framework to link like various data types together. So essentially, as long as I have some sort of data that's marked with latitude and longitude, we can get that to be synced up to that real world map with the projector. I'm not sure if that makes sense or not, or if that answers that question. But we're definitely going to try to do animation and motion on top of that map, whether that be like movement of like animals or like how water flows or things of that nature.
I think it did, and if Simon asked the question, Simon, if you have any follow-up questions, we would love to hear them. One of my questions for you, Damian, is, do you have other ideas of how to scale up the project? So you mentioned, okay, we're going to be doing this for next semester. Do you have kind of a series of scaled up projects for the students with this technique?
I do have some ideas, and I think that's like listening to both Sam and Rehan's pro projects here. I think like a big theme here is like engagement. So thinking like what sort of hands-on things can we get students to do to like get excited about animation and visual effects, etc. One thing I want to try with this one is it's sort of they're solving a lot of technical issues like how to manage data and get it projected. It also has some sort of artistic implications where maybe we experiment with like if a student is really interested in 2D animation, maybe we try different styles and project that onto the map. I'd love to sort of scale it up into right now we're just doing like projected video. Down the line, I think it would be really awesome to incorporate some sort of interactivity to this installation, like whether it just be like a simple screen that people are using to queue up different things, or like kind of scaling it up into a more interactive classroom where, you could use like hand motion or detect how people are moving around the installation to trigger different projection events. And so that could kind of be an interesting thing to flow into like right now we're doing this in an animation class, but then it could flow into like an interactivity class and use this sort of same setup.
Yeah, I love that. That is very, very cool. I think your students would actually really like it a lot. Thank you, Damian. I'm going to hop around with questions so that everybody gets a chance to answer some. So Samuel, one of the questions I had for you, your project seems like it really was able to bridge some of these gaps in knowledge and engagement that your students had, and they're really excited about post-processing, the post-processing techniques and color and image processing. Are you going to introduce these concepts more in the beginning now as they asked, or are you like, how do you plan to take these projects forward?
Yeah, I've been thinking about that. I think one of the reasons why they want to see this put first in the course is because, so at this stage, we were doing programming in Python and OpenGL. And as you may know, it's very boring to be there coding without seeing very complex scenes like you can see in a game engine. And so at this point, when I introduced post-processing, I also took the opportunity to introduce a game engine, in this case, Godot. Yeah, because one of the things I also considered when I did the aerographics paper on this course was that having a game engine being introduced here, it's also advantageous for those students that don't have so much technical skills, and because it bridges all the concepts into a platform they will be using throughout their career, right? Most of them will not do raw, hard computer graphics. They will work at a higher level. And so I think they find it very interesting to see the game engine there, and they wanted to be on the game engine from the start. So I think one of the, at least some of the students wanted to see that at the beginning because of that. But I do consider they have a point in how I can motivate them by showcasing a lot of these things at the beginning without opening the Pandora's box. Just, hey, look at this, look at how you can do things. Mind you, oh, hey, this has to do with image processing. We will see that later. This is this part of the graphics pipeline where you work with textures and so I think I can take on the materials I gathered for this part and use them at the beginning as motivational material. Yeah. And then I will unveil this a long time, maybe telling a story and just unwrapping, opening a little bit of the Pandora's box for each of the concepts as we go. Yeah.
Do you think you'll invite some of your former students maybe back to the class to give a presentation on what they learned and how exciting it is?
That would be a very interesting idea. One of the things that already happens is that they spread the word. So many of the students I have each year They just came by advice by other students that just did the course on the previous year because they want to know more about computer graphics, they want to be able to develop a game, etc. And so somehow that is already happening outside of the classroom because students are spreading the word about it. What I do is one of the elements I ask at by the end. So just to give a context, they have two basic assignments. One assignment is they need to write a small paper about an advanced topic in visual computing, and the other assignment is they have a group project where they need to showcase their mastery of the concepts or of the basic concepts in visual computing or advanced concepts they want to explore. This is part of what I was talking about, to having a student-centric learning path. So students with less technical skills can explore more basic stuff, and students that already had computer graphics, for example, can go to the nuclear bomb. And so in this project, by the end, they need to deliver a short report, and I advise them very strongly to make a video. And so I have videos of all the projects that have been delivered, showcasing all the features of the projects. And I use these at the beginning of the course. For the best projects, I showcase the videos. Say, hey, this is where you can go. This is what I expect from you. These are illustrations of the things you can explore. And I always urge them to go outside the box. So because there's a tendency, I don't know, others can say how they feel about their students, but there's a tendency, hey, I'm doing this course, I already have computer graphics. I will just do a project similar to the one I did. It's a less course for me to worry about. But I always urge them to go beyond what they know. And what I value is that extra step. So if I know a student already has concepts of computer graphics, I try to work with them when negotiating the project to go further. And without being afraid, they can go further. And if they fail, I will value that effort. So that's how I manage that.
Oh, that's really great. Also, you're making all these wonderful videos. Please, everybody, remember that you can submit to CGRAPH faculty student submitted work. And so you could submit your student work so you could showcase all this wonderful work that everyone is doing.
Cool.
Thank you, Samuel. Rehan, I've not forgotten about you. I really loved your presentation. You cover a broad range of practical knowledge with your students. What are some of the outcomes that you have found? Like, do students gravitate towards a certain knowledge set? Do they want to explore more a general knowledge set?
So the visual studies unit that we had was specially put in because for their capstone projects, students were directly jumping into production rather than taking a step back and really doing their primary research and looking into articulating and understanding real world aspects of whatever they were producing. So yes, in that sense, there's been ever since we introduced this unit, it was hugely popular with the technical art students. So back in the day, we had three courses: BA Visual Effects, BA Technical Art, and Art and Design, Animation, Art and Design. Art and design students already had that grounding with the kind of knowledge they were coming in, but technical artists who were more into programming and software, it was a good equalizer for them. The other two courses, the visual effects, or the units rather, visual effects, storytelling and pre-visualization, and camera acquisition units. Those are specifically for the visual effects students. And with that, certainly it gave them a good understanding of cinematography, of filmmaking. So what I've shown here are more the workshop elements, but the theoretical side of it is looking at cinematography and filmmaking, and wider art in general. So certainly that helps their understanding of engaging with and drawing from the broader creative disciplines.
Have you seen an increase in quality in their capstone projects and their final projects because they're getting this knowledge now?
Yes, and one of the key things I think historically we've had is the fact that they now ground the camera, even if it's an all CG project. Some of the th things that used to happen was, the camera would be flying all over the place sometimes, and you'd be doing a Matrix 360 and whatnot. So it's about building that film vocabulary, making sure that they're not using excessive lights and they're really conscious of where they're placing their lights and the light properties and how it's going to interact with the rest of the scene, and being diligent with their placement and number of lights, as well as rendering and indirect lighting and so on. Scale is a big one as well. So even if they're doing like cartoony film, um, scale is really key, scene scale, for simulations, for getting a reference of the entire world scale, match move, and everything. But even for like fully CG projects, um, I tell them, that even if it's kind of a fairy tale world where there's a cottage, I tell them to, go to, some of the Home Depot sites and so on and get some measurements for what is a standard door and work to that, building everything in that respect so that there is a sense of scale, even though it's highly stylized and you might have very different dimensions for different objects, but at least you have a grounding and a place to start from. So yeah.
Wonderful. That's really great. I love to hear that they're learning the concepts. Fabulous. We have another question for Damian, which is, could you share how it originated and how you connected with the client, and what will the end result be?
Yeah, definitely. So I'm actually I'm in Pennsylvania, as I mentioned. I was from Florida, just moved here last year. So I don't have like a wealth of connections. So I rely heavily on the faculty I work with. So the original connection was kind of set up by my faculty chair, who is very involved with the 3D printing world and depicting nature and knows a lot of the sort of local natural preserves and parks around here. So that's how that initial connection was established. Um, and that's something that my university has something called like a service learning committee. We're trying to establish sort of links to different organizations within the community to incorporate more of these service learning projects across like all of our classes. So we've done, for example, like the illustration class went out last semester and they painted all the dumpsters downtown. So I think that like with different murals. So I think this is kind of the beauty of being in like a smaller town and smaller university. It's very much like I feel like my faculty members like know everyone around us, so it's very easy to collaborate in that sense. But I also think it's good just to go places and ask like your community members like, oh, do you need anything? Could we collaborate with the students on a project? And I think just being more like real world applicable helps kind of motivate the students, especially I think a lot of students don't even really realize like what they can do with their artworks. For this project specifically, it's intended to be like a permanent installation at this park. So they have a little sort of welcome center, and that's where it'll be situated. And so hopefully, when people visit, they'll just be greeted with these projections that the students create, and we'll just keep on kind of building on to that framework.
Oh, that's really cool. I love that you're doing service-oriented and community oriented projects that really bring our local community into the classroom. That's really great. And kind of with that, I want to ask Samuel and Rehan, are you thinking of doing something similar as to what Damian is doing, or have you already, where you're working with your local community, or you're reaching out to people in the industry to kind of enmesh or incorporate into these projects that you're working on with your students?
Samuel, do you want to go first?
I can. So the course I teach is a course that provides basic level knowledge on visual computing. And the course is part of a program in digital game design that is designed around a project-based learning approach. So typically, the work they do in my course does not address directly any aspect of that is driven by the community, unless the students, when they propose the projects, they already have a goal, I don't know, for an association they have, or for a certain project they have of gamifying something and they want graphics on that. But I still haven't thought about that. The only way they are, or this work is connected with the community is, for example, when where their game project is connected or driven by the community. So, for instance, when their game results from the needs of an association to preserve the environment in a local reserve, for example, and they design a game for that. So naturally, what they do in visual computing can feed that effort, but there's no direct connection, at least at this point. It would be very interesting because actually I have two kinds of students. I offered this is a mandatory for game design, and it's an elective for computer science students and mathematics students and so on. So maybe they can bring something here with that purpose. Thank you. Yeah, it's interesting.
You're very welcome. Rehan?
Yeah, so in the past, what we've had is engagement from the community on what was known as the Festival of Learning. We would have the wider community coming in, and we would be designing sessions, bespoke sessions for a more generalized audience. And those were very successful in the past. At the moment, one of the things I'm planning to do is actually looking at engaging with people from disadvantaged backgrounds and trying to have kind of a parallel system where we can work with them and train them to basically not just tell their stories, but give them some inroads if they haven't had a chance at higher education into the wider computer animation and visual effects disciplines through training and basically providing the resources in a way that they can then connect to the industry. Interestingly, I was working at a visual effects studio where they were very keen on something like that as a bridge, and that idea has stayed with me because, yeah, it's giving back to the community, which is great.
Yeah, it's always wonderful. So another question for all of you, and I think some of you have answered it a little bit, but what were some of the surprising outcomes that came out of your students' projects, or that you didn't think would occur? I mean, I know, Samuel, you found that students were like, hey, this is so great, why don't you work it into the beginning? But were there any other surprising outcomes that the three of you found with these projects you have with students?
Yeah, Damian.
Samuel, you want to go?
Now you're gonna stay. No, you first. You first.
Well, I'll just say something quick. Well, this is in progress right now. So this, who knows, this could be a disaster for all. But I would say in general, it's kind of like the blessing and the curse of these like these smaller sort of classes where you have a different diverse student group where some are technically minded, some are more like traditional art minded. Um, you never really know how it's going to end up in the end. I would be interested to hear more about you two talking about like how you like balance expectations between those groups of students. But I would say I have done like different projects like this on a smaller scale, just this sort of like more service interdisciplinary type thing where we did like a little animation for the jazz band performance in town. And I think when the students can actually go there and see something and see that other people are seeing things, it definitely excites them. So whether that's like community based or even if you all are showing your work to, little festivals or sharing it with other students, like Samuel's talking about all the other students talking to all of them, and you have this little like swarm of enthusiasm starting to be cultivated. I think that is a great effect.
Yeah, in my case, I think one of the things that always surprises me is, well, I have very students with very diverse backgrounds. So the idea of the course is to have teams developing games that have different profiles. So we need to have the artists, the sound artists, and the developers, and so on. And so this means that some of them have never programmed in life, right? And they get very worried about, so how can what I'm going to do with my visual computing project, right? Because I will fail the course naturally. And suddenly, I think my effort, and sometimes this also means that I need to work extra stuff to be able to go into. So of course, someone that works as an artist in multimedia knows more stuff of that topic than me, and sometimes to push them a little bit on visual computing, I need to go and get their language so I can push them in the right direction. So, for example, if they are used to working with Blender, I can work with that for a project in visual computing. They can explore things like view-dependent mesh simplifications. They can work on the game engine inside Blender without doing one programming line. And so they get motivated with that. And I always find it very interesting to see that by the end they have a project that they don't get ashamed to see the projects of the game developers, right? All very sophisticated, and then they realize they are also able to explore the concepts and even, for example, have success. If I have 1 minute, I have a particular case of someone that went into a company after doing this course, and it was a person from multimedia, and she was very good at modeling and Blender and stuff. And when she arrived to the company, they said, oh, so we're going to work on mesh simplification and view-dependent simplification for artifacts and things like that. And she knew about the topic. She knew the concept. She worked on it in Blender. So she felt ensured that she did a good work. Yeah, so that's rewarding.
So for me, it's just been amazing to see sometimes that the students going all out with, for example, in the storytelling unit, with full costume and makeup and everything, and making sure that um, you can see the motivation and the engagement coming out, because they're just so into it. Similarly, for visual studies, I've seen some amazing studies looking at anthropomorphizing characters, and one I remember distinctly is the swan dance from Swan Lake, where the student had actually articulated and mapped the human joints onto those of a swan, and got to amazing detail. Same with another one with jellyfish, which was then, in the choreography of the whole dance, looking at the swan movements and human movements and how far they can be pushed and exaggerated. So it's just phenomenal.
We got to get the painting robot to
I
paint
know.
the.
Yeah, that would be, yes, let's bring that together. We have another question in the Q&A from Lynn. This is for Samuel. What other methods have you tried to increase interest in image processing, and how have these other methods worked for different student populations?
Huh. Good question. I do confess this was the traditional method I had implemented was the one, so I explained the basic concepts, and then we moved into the traditional approach using libraries as OpenCV with a lab guide, and so do this, do that, filter the image like this, use this kernel, and I think they didn't engage. First, because it's very different from computer graphics. It's sometimes when you talk about convolution and kernels, they get afraid of that, and they were already focusing on the project. I think one of the things that makes them go the extra mile is at least, and it seems that everyone here is doing that, is we give them a lot of freedom to choose the topics they want to pursue, and we guide them for to tune the complexity and to make sure that they explore the concepts. And so that motivates them a lot. That part in the image processing was not part of that. And so I was not motivating them enough. So the change I made from that traditional approach was the one I explained here, of reframing all the concepts as part of the graphics pipeline. So that's the first big experience I did in changing it, and it didn't work that bad. So I'm going to refine on it and apply it next year and see. There's already some ideas, right? Bringing students to present their early work. So I'm going to take a list on all the suggestions I already had here. Thank you.
Excellent. So I think some of you have answered, as Samuel, you just answered kind of how you're going to scale this up. And Damian did a little bit, and Rehan, but I would love to hear from Rehan and Damian a little bit more how you are thinking of scaling up some of these amazing projects that you're having with your students and getting all these great results.
So for us, it's actually cutting back, unfortunately, because we used to have three distinct courses on the undergrad. Now we've consolidated all of those into one with options. So in that sense, the visual effects photography and acquisition hopefully will still remain an option going forward. But one of the things that happened was, unfortunately, the studio practice element went out, but has been reintroduced. And so that's now kind of merged in with a first year unit called Lighting and Look Development. So at the same time as doing the workshops, they're also working inside a DCC. Which I think will help actually drive home the concepts of exactly what they're doing in the real world and how they're kind of setting it up inside the software. So I think that may be a good thing. Let's see how that goes. The visual studies, so the research element is now part of the capstone project, which was a 60 credit final year unit, which is now 20 unit for R&D and then 40 credits for production. So I will be leading the research and development in the third year rather than the second year. So that will evolve and continue as well, which would be interesting to see.
One thing that you said, Rehan, like with the I feel this kind of struggle within me with like the specialization versus generalization of courses. I don't know about all of your institutions, but our animation program is pretty small, so I have to keep things more general. And I wish in some parts of me I could have like a specialized course for like everything you're saying, like photography, visual effects, all these little courses. But like the reality of at least where I am is uh like in higher ed in general, I think is like thinking about like enrollment numbers and budgets and all like this. How do we get the students into the class? Which is, I think in some ways can be good. Like it's kind of like spurs you to be a little more creative with how you teach some of the content. But I would say like that's what I would try to incorporate into these courses. Like how can I get the technical skills that like you all are talking about mixed with the enthusiasm engagement with the limited number of credit hours at my disposal. So whether that is like seeking more interdisciplinary collaborations with like other faculty, I think that would be like a great way of going about it. But that's sort of like what I've been thinking about when I'm crafting these assignments and projects.
Um, Rehan, you mentioned research, and I think research is so important for our undergraduate students because oftentimes they don't get to do it. Samuel and Damian, have you thought about incorporating a research element into your projects as well, like maybe having the students create a poster regarding some of the concepts they've learned, or write a paper and then maybe submit it to conferences like CCRAF?
I am now. No, but I haven't in the past, but I think that would be a very much beneficial for the students.
Uh, yeah, I do consider that that looking into at least into the basics of research is important. The first assignment for visual computing is to write a small article about an advanced topic, and then I do peer review. So everyone in class receives two papers from colleagues and needs to review them. The idea here is for them to read about two advanced topics besides the topic they wrote about. Of course, most of these articles are not submission material because they don't have nothing new. But I'm this year, I'm considering, and we're trying to do that, to submit student projects to, not to SIGGRAPH, sorry, to aerographics. We're trying to submit two student outstanding projects to aerographics and see how it goes. But we'll look with much love to the proposal of submitting to SIGGRAPH. Thank you.
Excellent. And Rehan, what about you and your students? What does the research kind of look like once they develop it? Is it papers? Is it posters? Is it presenting at conferences?
Yes, so we have the unit in particular that I was talking about. It's major project research and development, which is very much the kind of primary and secondary research you do for the project itself, very much focused on that. So if you're creating a dragon, I would be encouraging them to go and look at reptile skin, anatomy of birds and bats, and so on, and large creatures, how they move, and so that's very much focused on the project at hand. But we also have a separate unit that one of my colleagues runs, and that is research and development. Is now called, I think, emerging technologies, which is very much focused on the undergrad research in the more conventional sense. So they can choose their topic and they can go and develop. It's all about innovation. So a level of innovation that we expect at that we would expect at undergrad level, and we do have regular SIGGRAPH posters coming out of it. So yeah, that's great. Um, Very quickly, just coming back to Damien, your point about the pressures, and certainly with all the camera teaching, we've grown from when I joined the university back in 2006, 2007, it would be one classroom of 45 students. Now it's 160. So if you start teaching studio-based components at that, at a cohort that big, it becomes quite interesting in terms of repetitions, because you can't really teach all of this stuff as a lecture. You can only have a certain capacity for delivering it in the studio. So I'm delivering, I think, 6 or 7 repetitions starting next week, which is fun. But obviously, then there are, again, other pressures in terms of the financial pressures, timetabling, equipment, resourcing, all the rest of it. But I think in terms of value, the university really acknowledges that, and so is happy for me to continue with this stuff, so which is great.
Well, I am sad that it looks like our time is up, but I really want to thank all 3 of you. Everyone, please put your hands up. This is the yes, for Samuel, Silva, Damian, Thorn-Hauswirth, and Rehan Zia. This is clapping and sign language for our session panelists. Thank you so much.
Thank you so much.
Thank you very much. Thank you.
Thank you.
And I'm going to hand it over to Nick.
Thanks so much, Mayette, for hosting. Thank you to all of the presenters. That was awesome session.